Okay guys, we're going to start here with our new unit, characteristics of electricity. Okay, so this is our last unit. We're going to move through it pretty quick and I'll give you all the main points that are important for you. Important for you to know. Okay, a shocking experience. Have you ever received an electrical shock of some kind? So sometimes people will think, no, they haven't, or they think quite dramatic things for this. But realistically, if you've ever experienced static, something clinging to your clothes, that's electricity. If you've ever had your hair stand up like this little kid on the slide here, that's electricity. That's a shocking experience. If you've ever had your fingers zapped when you touched a metal doorknob, that's another example of that. So all of these are examples of things that are caused by electric charges. So electric charges. So electric charges there are all very small, and when they build up, they can cause very large, big displays here. So this is an example. This is a picture of lightning, of course. And this is from Winnipeg, so that's a pretty significant lightning bolt there. And in your notes, you can just sketch a quick little picture of a lightning bolt there. Okay, so we're going to take a look at activity, the activity on page 206 in your textbook, so you can take a look there. The first part of the activity, you're supposed to charge up a straw, so you can do that, but a lot of people don't have plastic straws anymore, so you can use a comb. If you have some sort of comb, maybe run it through your hair, and what you should see happening, as long as it's not too humid, you should see getting some static on it. Now, once you've done that, you're going to bring it close to a bunch of little pieces of paper. So just cut up a little bunch of pieces of paper here and just see what happens. So hopefully you have done that, and what ends up happening is these little pieces of paper are drawn to the comb and they're going to stick to the comb. The second part this was the first part here. The second part here was with balloons. So if you have balloons in your house, I suggest you try this as well. So you can charge up balloons, make them full of static electricity by rubbing them against your hair again. So if you do that, you're going to get charges built up on those balloons, and then if you do that with two balloons and then you bring them close to each other, what you'll end up seeing happening is they're going to repel each other. Okay, and then but if you flip the balloon around, they can attract each other. But I just want you to read through the activity on page 206, and please, if you have the supplies at home, please go ahead and do it. It's kind of fun to do that kind of stuff. Okay, so review from chemistry. So protons, electrons, and neutrons, do you remember what these are? So protons are positively charged particles. Positively charged particles. Electrons then are going to be the negative ones, right? So negatively charged particles. And neutrons are neutral, I'm just going to say neutral particles. Now, which ones are found inside the nucleus? Yeah, protons and neutrons are found inside the nucleus, and where are the electrons found? Outside, and they are in the shells or the orbitals outside of the nucleus of an atom. Okay, so we're going to use these concepts of electrons and protons and neutrons. Well, we're not actually going to talk about neutrons, but protons and electrons, and this moves into our electricity unit here. Okay, so static electric charges. So objects can become charged when electrons move from one object to another. And it's important to note it is the electrons that move, nothing else, okay? Because remember, where are the protons located? Inside the nucleus. So they are not free to move. It's only the electrons that can move. The charge that builds up on the surface of an object is called a static electric charge. If an object has more negatives than positives, it can be considered to be negatively charged. If an object has more positives than negatives, it's considered to be positively charged. And we would have talked about that in our chemistry unit here. So for example here, this is our neutral object, this one, so we've got equal numbers of positives and negatives. If something has a positive overall charge, that means we've got more positives than negatives. And if something has a negative overall charge, then we have more negatives than positives. All right, next. Whoops. Okay, so friction. One of the ways that we can charge objects is through friction, and that's what you did when you ran the comb through your hair, if you did that, or when you rubbed the balloon on your hair. Now, objects can be charged through friction. This is when two objects are rubbed against each other. This causes some of the electrons to be stripped off of one object and deposited on another. So this couple, ooh, geez, yikes. I'm not sure how that happened. Hold on, everyone. Where are we? There we go. Technical difficulties. So this part here, this part here has to be written down on your notes there. So define what friction is there. So this is a little animation here that just shows if we've got the neutral cloth, and then we've got a neutral PVC pipe. If we rub them together, what ends up happening is the electrons are stripped off the cloth and what is going on? And put on the pipe. Sorry guys, I don't know what is happening with my iPad. Maybe it's something with that GIF, I don't know. I'm gonna get past it. So the electrons are getting deposited from the cloth, they're stripped off onto the pipe. And I'll let you sketch a little diagram showing that. So you wanna show the electrons moving from one thing to another. And that's how we charge by friction. Now, it's again, always remember only the electrons move, not the protons. Now, laws of attraction and repulsion. So lots of times you already know this. You've heard opposites attract, right? So what that means by opposites attract is that when you have positive and negative charges, they like each other. So they are going to attract, and that's this one here. If the charges are the same, they're going to repel. So if we look here, two negatives don't like each other, repel. Two positives don't like each other, repel. If two things are neutral, they just stay, they're neutral. Now, incidentally, neutral is attracted, so neutral objects are attracted to both positive and negative objects. Okay, so you can add that into your notes there. Okay, so remember insulators and conductors. So once again, we did talk about these in our chemistry unit, because we talked about the properties of metals and nonmetals. So insulators will not allow electrical charges to move. So the electrons are not able to move. Conductors do allow the charges to move. So here are some good examples here. So good conductors are things like copper. So I chose copper here because copper wire, a lot of electrical wire is often copper wire, so the charges travel very easily through copper. Other metals are also good conductors. Fair conductors, so these are conductors that are okay but not as good as metals. So water with dissolved minerals in it. So yeah, if you have stuff dissolved in water, it will conduct electricity. Moist air, so air that has some water in it, are fair conductors. Human body, we are also conductors. Electricity can move through us. And soil we can have electricity move through soil as well. Now, insulators, these are things where electricity is not able to pass through, things like rubber. That's why a lot of handles for things are often made of rubber. Wood, you can't pass electricity through wood, plastic, or pure water. So by pure water, I just mean if it's just H2O just by itself, you cannot pass electricity through it. Okay, so your assignment is going to be in your textbook from page 211, questions 1 to 7. Okay, and I'll post more about that on the website for you.